Hey everyone, welcome to video lesson 12.1, Rationalizing with Conjugates. Before I go into this lesson, I've got started so I don't take too long with this lesson. Okay, so recall that when you're dividing complex numbers, okay, you need to have complex conjugates. So if you have a plus bi, then the conjugate of a minus bi. So notice bi is the one that changes the sign. So change the sign of bi. So when you multiply them, the I disappears. So for example, 2 plus I times 2 minus I gives you 4 minus 2I plus 2I minus I squared. But negative 2I plus 2I, they cancel out. And then don't forget that I squared is equal to negative 1. So then you have minus a negative 1, which is what I have here. So then you just add 4 plus 1, which is 5. So in the end, there is no I left, okay? So that's the idea with conjugates. So I've done a few examples, which I'm going to explain. Next, so when you multiply radicals, which is what the previous lesson was about, you multiply 2 times 1, which gives you a 2, and 2 times 3 square root of 7. 2 times 3 is 6, and then just tag along the square root of 7. And then square root of 7 times 1, that's just 1 square root of 7. And then square root of 7 to square root of 7, that's equal to 49. So you have a 3 in front of that, and don't forget the square root of 49 is 7. So you're basically multiplying 3 times 7, which is 21. But then we have a 2. When you combine this 21 and that 2, they give you 23. And you have 6 square root of 7 plus 1 square root of 7. It's like saying 6x plus 1x, that's 7x. But instead of x, you have the square root of 7, which is how I got this. Okay, so that's the first example. The second example, square root of 18 is you can simplify, right? So that's what I've done here. 18 is the same as 9 times 2. And we know 9 is 3 times 3. So then the multiples, the prime numbers that are multiples of 18 are 3 times 3 times 2. Since we have 2 3s, we can take a 3 out. So that's what I did here. So 1 is negative because you have a minus in front of it, and this one is positive, right? Okay, so I changed this to this. And then we do what we did on number 1, which is we're going to multiply. So we multiply 2 times 3, which gives you 6. 2 times 3, square root of 2. 2 times 3 is 6, right? And then just tag along the square root of 2. And then move on to the next one. Negative 3 square root of 2 times 3. Well, negative 3 times 3, that's a 9, right? Negative 9, and then square root of 2. When you multiply negative square root of 3 times 3 times square root of 2 times positive square root of 3 times positive 3 square root of 2, you multiply negative 3 times 3, which is 9, and then 2 times 2, which is 4. But then again, square root of 4 is 2, which means you're multiplying negative 9 times 2, which gives you a negative 18. Since we have negative 18 and positive 6, when we combine those two numbers, we end up with negative 12. And then when you combine 6 square root of 2 minus 9 square root of 2, you end up with negative 3 square root of 2. Okay, so this is a review from the lesson on the previous two lessons. And last example. So notice, these are conjugates. This is plus and this is minus. Instead of bi, you have a radical, but it's the same idea. So when I multiply 3 times 3, that gives me 9. And then for this one here, right, if I multiply, let me see, I need to write this down. So let me so you can see it. So when I multiply 3 times 3, that gives me 9. And then 3 times negative square root of 2, that's negative 3 square root of 2. And square root of 2 times 3, that's positive 3 square root of 2. So as you can see, those cancel. And then negative square root of 2 times negative square root of 2, that's negative square root of 4. But then again, we know that this is negative 2, right? Because that 4 square root of 4 is 2 and has a negative in front of it, so it's negative 2. And when you combine 9 and negative 2, you're left with 7. As you can see, there's no radical left, so it's just a number, just like we did with complex numbers. Same idea. So problems like number 3 are called conjugates, and they look like difference of squares, okay? They remove overall radicals, so once you're finished, there should be no radical left. It's just a number. So if the denominator is a binomial, you will have to use conjugate to rationalize the denominators. So I'm going to do number 4, and then I'll explain number 5. So for this one, we have 7 plus square root of 6. That means we got to multiply by its conjugate, which is 7 minus the square root of 6. And we have to do that to numerator and denominator. Okay, so just the opposite sign. So then 9 times 7, that's 63. 9 times negative square root of 6, that's negative 9 square root of 6. Denominator, when you multiply 7 times 7, that gives us a 49. 7 times negative square root of 6, that's negative 7 square root of 6. Positive square root of 6 times positive 7, that's positive 7 square root of 6. And then square root of 6 times negative square root of 6, that's negative square root of 36, right? So then again, notice these two cancel because it's negative 7 plus 7. And then this becomes a negative 6, right? So then I'm going to leave the numerator the same, 63 minus 9 square root of 6 over, I have a negative 6 plus 49, that's a positive 43. And now think about if we can simplify this, right? Do 63, 9, and 43 have any multiples in common? So you might think, well, 63, it's the same as 3 times 21, and 9 is the same as 3 times 3, so there's a GCF of 3 on the numerator. But 43, this is a prime number. You can't simplify this one. So therefore, you can try, but if it doesn't work, just leave it like this. Okay? All right, so next example. You have a 5, denominator is 8 minus the square root of 6, so then the conjugate is 8 plus the square root of 6. So then once you write the conjugate, you start multiplying. 5 times 8 is 40, 5 times square root of 6, that's 5 square root of 6. Now let's go to the denominator. 8 times 8 is 64, negative 8 times square root of 6, that's positive a square root of 6, and then negative square root of 6 times 8, that's negative a square root of 6. So as you can see, those two cancel. And then negative square root of 6 times positive square root of 6, that's negative square root of 36, which we know it's negative 6. So when you combine 64 with negative 6, you're left with 58. So now for this one, you can also try to simplify. So for example, denominator, 5 goes into 48 times. So there's a GCF of 5 they can factor out. But 5 doesn't go evenly into 58. Therefore, we don't need to do anything else. Okay, we can't simplify that one. So that's just 2 examples on how to apply conjugates. So I'm going to give you 2 more examples. And in this case, what I'm going to do is I'm going to simplify the denominator. So this is negative 3 square root of 5. Denominator, the square root of 4 is 2. So this is the square root of 7 minus 2, right? Okay, now think about this. We see that negative 2, so you might feel confused about this. But the one that needs to have the opposite sign is the 7. So if it helps you, rearrange it. If not, just follow it like this, okay? Just follow along. So what I'm going to do is I'm going to multiply by the negative square root of 7 minus 2, numerator and denominator. So negative square root of 7 minus 2 again, because this is positive, I need the negative, so they can cancel out. All right. So then to that end, negative 3 times negative, that's positive, and then 5 times 7, this is 5 and this is 7, that's 35. So 35 inside of the square root. And negative 3 times negative 2, that's positive 6, and then just tag along the square root of 5. Okay, so that's so far the numerator. Now let's go to the denominator. So positive times negative, that becomes negative, and then square root of 49 because it's 7 times 7, right? And then this one, square root of 7 times negative 2, that's negative 2, square root of 7. And then next, negative 2 times negative square root of 7, that's positive 2 square root of 7. And negative 2 times negative 2, that's positive 4. And again, as you can see, these two cancel. So then let's continue simplifying. So we have 35 is 7 times 5, so we can't simplify anything from there. So just leave it as 3 square root of 35. And then the denominator, we'll see, so 35 plus 6 square root of 5. Denominator, this becomes, I hope you guys can see it, 49 square root of 49 is 7, but this has a negative in front of it, so that 7 is negative. So then we have negative 7 plus 4, that's a negative 3. So now watch this one. There is a GCF of 3, right? So I'm going to factor it out. So this is 3 times the square root of 35 plus 2 square root of 5 over negative 3. So what happens here is the 3 reduces, but don't forget we have a negative, so then both of these terms become negative. So the final answer is negative square root of 35 minus, let's see, 2 square root of 5. Okay, because if this is negative, then the whole expression is negative. And that's the answer to that problem.